Hey everyone, so welcome to part two of my video series on the LLM mini hackathon that I did for building on Simon Willison's LLM command line tool. You will find links to both the LLM tool and also to this notebook, this write-up notebook underneath the video. So first of all, there's three projects that I'm going to cover, two runners up and one winner. So I'll start with the runners up and then we'll move on to the winner. So the first runner up by Evan Mullen was looking at this website called Doctor of Credit, and the website looks like this. And essentially, what this website does is it aggregates bank bonus offers. So when you uh, deposit your money at a bank or you open up a credit card account, sometimes they will offer you a $50 bonus or $100 bonus or whatever. This website finds those like current offers at different banks and it aggregates them with details for each offer. What do you have to do in order to apply, in order to qualify? How big is the offer? How long do you have to leave your money in the account? Do they do a hard pull or soft pull on your credit card? That kind of thing. So, the developer Evan wanted to extract this data in a structured way so that he could run some calculations to see, given the amount of money he has to put into an account, which of these offers gives him the best ROI. So, in order to do that, he wanted to get the HTML from the website, clean the HTML, to convert it into text so that it's, strip out all the HTML tags so that it's a shorter input. And then we'll use LLM to convert it to JSON data. Um, Fairly straightforward to do, although the main challenge here is that the website is dynamically rendered, so normally you would use curl or wget if it was just a static web page to get the HTML content. Unfortunately, you can't do that with this web page. Um, he For his project, he just like went out and got the HTML manually, but I've written up a little explainer here of how to get dynamic web page HTML from the command line. So the tool that you would use is actually Google Chrome. So if you have Google Chrome installed on your computer, you can do this from the command line. Like once you've got that setup done, you can accomplish this whole thing with just like this chain of commands here. So we use Google Chrome and we pass it flags that say, okay, we're gonna use it headless. We're gonna disable the GPU, so we're not actually gonna render the page, and we're gonna dump the DOM, which means we're taking the HTML from the page and we're dumping it into standard output, and then you pass it the page link. So this will get you your HTML. And if you want to, you can drill into the details of why those flags, but I will leave that aside for purposes of this video. Because really all I'm doing is sort of pitching Evan's idea here and telling you why it's cool. Um, then you pipe it with this pipe operator. You pipe the output of the Google Chrome command to the strip tags, and that takes the HTML and converts it to text by stripping out all of the HTML tags. And this minify says, let's also get rid of the white space, the blank lines. And then we pipe that output, the plain text, to LLM, and we give LLM a prompt and tell it sort of which data we want. And we also give it a schema. Um, so this schema multi means if you just pass the schema flag, it'll give you a single JSON object. If you pass schema multi, it'll give you an array of JSON objects that match this schema. So you then define your schema. So we've got the name of the bank, which is a string. We've got the bonus name, which is a string, deposit amount, which is an int, deposit duration, which is also an int, and we tell it in the prompt we want that in days, we want the duration in days. And then we have this like notes field for additional information. I mean, this is kind of like arbitrary. You could improve on this. And actually, if you were going to use this in practice, I would suggest doing an actual JSON schema like in a file, because some of these fields you will want to be nullable, and this concise schema syntax provided by LLM actually doesn't support optional or nullable fields. So you would have to pass it a JSON schema file in order to get nullable fields. If you don't have nullable fields, sometimes the LLM will just hallucinate in order to put something in that field, even if there's no information available for that. So in order to avoid hallucinations, you've got to have nullable fields. But for purposes of demo, we'll use this concise schema syntax. As I mentioned before, the extract flag, which is also dash x, um, that will extract a fenced code block. So if the AI returns the JSON with like sometimes it'll put triple backticks around the JSON, and it'll put a little like header on it to say this is JSON out. This is a JSON code block. This extract flag just says like if we encounter that, let's strip out those tags at the start and finish, and just have the JSON. So anyway, you run this command and you will get your your results. So let's just do it right now. And that will write the output to this results.json file. And hopefully, momentarily, we will get output. Okay, let's see. Let's open up the results file, cursor results.json, and see what we got. Okay, yes. So we in fact got this JSON. It puts it all on one line, so it's not pretty. But if you wanted to, process this, it does have, integer values that you could use for calculating ratios and that sort of thing. And you could always put this through a JSON prettifier to make it more readable if you wanted. So that's the first project. I think it's pretty cool. It's a, very practical use case and something that like with long as you just save this command, it makes it very easy to come back later and do this again. Um, and you do it just with one command, which is pretty cool. All right. This was my project, another runner-up. And my idea was that we can take any command line tool and we can create a natural language version of it that's powered by LLM. So the pitch here is, let's take the help output. So if you have a command line tool, usually if you use this help flag, it will give you like a pretty detailed accounting of what sort of subcommands are available, what the arguments that you can pass to them are, and sort of how to use those arguments, right? So as long as you've got this help output, usually you can figure out how to use this command line tool. So my idea was let's take that help output and let's just like feed it into LLM as a template so that we always have a template showing how to use that command. And in that template, we can instruct LLM, use this help output to generate a command to achieve the user's objective with this tool and only return the command, no other text. So, and then we use the save flag to save it as a template for, I'm using repo mix as my example. So, generate a repo mix command and then we save it as the repo mix template. So once you create this template, I'll just go ahead and run command to create that template. Then you can use the template with the template flag and the template name. And so we can just go like this. Yeah, so we can provide it a prompt, pack all the markdown files in the current folder, indicate that we want to use the repo mix template, and it outputs the correct command to achieve what we wanted. So it uses this include flag and says only include markdown files. Um, and that successfully will, if we were to run this command, it successfully would pack all of the markdown files in the repository. That's a correct and valid command. So, and then you can chain this output with bash. So you can take this, this command right here, put a pipe operator in bash, and it would send this command directly to bash, and bash would run the command. So I'll show you how that works. So if I just run that combination, it will actually run the command and pack the markdown files in the repository. So it's found two markdown files and it has packed them in repomix output.xml, which I could open up and show you. Cursor repomix.output.xml. And we can look at the accounting of files. And in fact, yes, it's only packed the markdown files. Okay, so that's the concept. So now how would we productionize that? So the product would be, let's take this pipeline right here and let's package that as an executable so that it's, a single executable that we can run with NL repo mix. We don't have to do this, LLM piping to bash. We can just run NL repo mix. So this script will do that. Um, and basically, as long as you've created a file with this NL repo mix, you then could make it executable and add it to your path, which I've already done. And then you can use it like this. So you would say NL repo mix, pack all the markdown files in the current folder. NL here just means natural language repo mix. So I'm saying like, let's create this natural language repo mix executable. And then it works exactly the same way as the pipeline we just ran. Oh, I guess I didn't create this. I didn't set this up. So I would have to, create a file and then do the executables and add it to path. But um, and then I could run that and it would work exactly like what we did above. Okay, so then how would you scale that? Well, actually, you with very little effort could programmatically create templates from any CLI tool. So you would, I actually created a sample implementation of this, which you can find a link to in the notebook. Um, and it looks like I actually have it here in my repository. It looks like this. But basically what it's doing is you pass it the name of your command line tool. It is creating an LLM prompt from the help output for that tool. And then it's creating a script to run the LLM prompt, generate a command, and then um, run the command. So you could programmatically then create natural language versions of any command line tool, which I think is pretty cool. I mean, there's still some like implementation issues you have to deal with because a lot of them don't just have one help output. They also have separate help outputs for all the subcommands. And for like the AWS CLI, there's like tons of these help outputs, and it would get very long if you programmatically tried to put all the help outputs into a template. You'd have a really, really long template. At some point, that breaks, even if you can figure out how to like recursively get all the subcommands to help outputs. At some point, I think you probably overwhelm the model. So, there are practical limits and also practical implementation problems here, but I think they're solvable actually. Um, but I'm just saying it's not a fully working implementation. There are still some engineering challenges you would need to overcome. Okay, so then the winner of the mini hackathon was Steve Sankis, and his project was taking the so-called Big Beautiful Bill, the budget bill that was just passed, and we're gonna scrape it and chunk it and embed it and then do RAG or semantic search over it. So retrieval-augmented generation. And actually, you can do this with just 5 commands, which is pretty amazing. This curl command will get you the output from the web. It will get you the full text of the bill from the web. And there's some like encoding issues, and so this just removes some of the encoding issues, and also we strip away the HTML tags to only leave the plain text. So um, that gets us a file, the budgetbill.txt file, and it'll download the full text of the bill and write it to this budgetbill.txt file. Okay, so then Steve named his project BBBW. If you know, you know. You create a directory to hold the chunks, and then you run split, and this is just gonna create 6,000 byte chunks. So it'll basically every 6,000 characters it splits the text. And that's maybe not suboptimal to be breaking like mid-word in some cases, but it's probably fine. It's not going to seriously degrade performance in your semantic search. It's going to save every chunk as temp chunk and then, some integer number. So it's going to do incrementing integers at the end of your file prefix here. So you pass it the length of the chunk with this dash B flag, and then the file name, and then the output file names. Um, and if you run that, so yeah, so you've got to run make dir BBW in order to create the directory, and then that will work. And it writes all those files. Okay, so that succeeded. All right, so then you can use LLM to embed the chunks. And basically what this is doing, it's creating a numerical matrix that represents the chunk of text. And that numerical matrix contains or in some way represents the meaning of the text in mathematical space. And if you create numerical representations of a bunch of different chunks of text, then there's a mathematical algorithm you can do to sort of say, like, let's find given any chunk of text, let's find the one whose meaning is closest to it in mathematical terms. So, and that algorithm is called cosine similarity. Um, that's technical way of saying we can do fuzzy searching. We can take two pieces of text and say not just like do they share words, but is the meaning of those two pieces of text similar to each other? And that is a cool thing that AI unlocks, is the ability to do that kind of searching. And when we convert the text into that numerical representation, we call that embedding. So you've got to select a default model for embedding. Um, so we just selected this text embedding 3 small, which is an OpenAI model, and you have to set that as your default text embedding model. Um, and then once you've set a default text embedding model, then you can use LLM embed multi, give it the directory, and say we want to embed all the files inside that directory. Actually, so this is actually the name of every record. It's going to write all the embeddings to a SQLite database, and it's going to give them a name so that you can search over a collection. So we have to assign a collection name. So that's what this is. This is the collection name in the database. And the files flag is saying, let's get all the files from this directory and embed them. Okay. So, and this is an optional, actually, we don't even need this, but this is a pattern matching string. So if you only wanted files that match a particular pattern, file name pattern inside this directory, you can use a regex string in order to match, basically, or a globe string, as they call them. And then we're this store flag says, let's not only store the embedding, but let's also store the plain text version of the chunk along with the embedding, so that we then, when we do similarity search later, we don't just return the numerical representation, we also return the plain text. So I always include this store flag when I do text embedding to make sure that I have the plain text version. All right, so we can run this command in order to embed our text chunks, and it happens very fast. Like, that's pretty impressive performance. And then we can do this LLM similar will retrieve chunks that match our search string. This flag stands for content. This is our search string, so we want to find things that are similar in a very fuzzy way to no snap for you. So if I, this is just kind of like a joking idea about what you might want to look for in the bill. You want to find anywhere that they have limited the SNAP benefits, the food stamp benefits. Okay, so this is my joking way of searching for that. So let's see if it can find anything that is similar in a fuzzy way to this search string. All right, so we run that command and it'll return chunks from the bill. So things related, hopefully, to SNAP benefits. And you can see there's still some encoding issues here. I mean, if you wanted to do this right, you would run some extra code to clean up those encoding issues. But let's see. I mean, it's hard for me to tell whether these things are related or not. Uh, but we can ask an AI to sort of look at the retrieved chunks and tell us whether there's anything related to Snap there. So I'm just going to do that. I'm going to take that output and pipe it back to LLM with a prompt and say, um, is the retrieved text build text relevant to SNAP benefits? And let's see what it says. So basically what this is doing is it's doing that similarity search and returning chunks, and then it's going to prompt the model. Sorry, the output here in my terminal got a bit garbled. That happens sometimes, but it says, yes, the retrieved bill text is relevant to SNAP benefits. It includes various amendments and provisions related to eligibility, requirements, adjustments to benefits, and the overall structure of the program. For example, it discusses modifications to SNAP work requirements for able-bodied adults, adjustments to state quality control incentives, alien eligibility for SNAP, and changes regarding administrative costs, among other things. These aspects directly impact how SNAP benefits are managed and distributed. So yeah, so actually our similarity search did find the parts of the bill that essentially could be summarized as no SNAP for you, which is that's like pretty amazing that you can use that search string and get relevant results and the information that you're looking for from the bill. That's kind of amazing. Um, Here's another example. You can search for anything related to agricultural policy and ask the LLM what the budget bill says about agricultural policy, and you get this like very detailed, sophisticated analysis. So I think this is really cool use case because so much of the rhetoric around these bill, the news media is going to zero in on like three or four things that are like really sensational in the bill, but there's tons and tons of other stuff in the bill. Maybe you as a citizen want to decide for yourself. But it's 1,000-page bill, so you can't read the whole thing. Like nobody's going to sit down and do that unless they're a professional journalist and they get paid to do that. So, like, how do you sort of quickly grok what the bill says about, policy areas that you're interested in? Well, you can do these searches and find stuff that's relevant to your interests and get I think fairly granular picture of what the bill's all about um, as interpreted by an LLM. So honestly, incredible use case and amazing that you can do it with like so little code, so few command line commands. And I think there's probably a million other use cases. I mean, I think this could unlock so much citizen journalism. People now have the ability, really this has always been the domain of lobbyists and journalists. There's been kind of an information monopoly over this stuff because, no, the citizens don't have time to know what's going on in their democracy. And with a few CLI commands, now you can know what's going on in your democracy. And I think that's pretty sick. So congratulations to Steve on his winning entry. And thank you for watching. If you're interested in this kind of content, maybe subscribe under the video. Thanks.